Today, we will understand limit state of collapse point to point as per IS 456-2000. So, welcome friend, another video on concept underscore civil. Hope you understand and get some value. So, in the last video, we talked till the 37.12 clause. From today, we talk about the clause number 38. Okay, the 38th number clause says that regarding limit state method. And previously, I told about there is three types of limit state. So it is limit state of flexure. So we understand what is the limit state of flexure. Flexure, that means collapsibility. So very simple word I can say collapsibility means this is your structure. This is your structure. So what is the maximum limiting force after that structure can collapse? So that is why this is known as your limit state flexure or limit state of collapse. So before starting this, everything has some assumption. Why we do the assumption? Because make it easy. Make it easy. So now we'll talk about limit state collapse or say flexure assumptions. Assumptions. Okay. So first assumption is the code saying that plane section normal to the axis. Normal to the axis. Normal to the axis. Suppose this is your section. This is your one. This is your one axis. So suppose this is your x-axis. This is your y-y axis. If you consider this x-axis, then normal means this y. If you consider the y-y axis, then normal means this parallel to the x-axis. So plane section normal to the axis remain plane after bending. That means first we understand, then we write. This is your one beam, and you apply the UDL. What happened? There will happen some bending. Will happen some bending, and the mid section is remain same after bending. So first point, plane section normal to the axis remain plane after bending. That means consider this diagram. Compression will be generated, tension will be generated, and the mid section is no tension, no compression, no bending. That will be neutral. That is why when we start the RCC design, we say this is your neutral axis. Neutral axis where no tension, no compression, no bending, no shear, you can say. Neutral from every kind of influence of the force, everything. So that is why we say this is your neutral axis. Okay. Let's jump to the number 2. The maximum strain in concrete at the outermost compression fiber is taken 0.0035. So strain of concrete is 0.0035. Why? They mention the for the concrete steel. Why not steel? Because concrete is our brittle material. Brittle material means no expansion, sudden failure, less ductility. That is why, by experimentally, we observe that if this is the diagram of our typical RCC section, and this is your maximum compression zone, and that value should be 0.0035. But why not steel dimension? Because I think that steel is your tension member. Okay, but main reason is steel is your brittle. No, steel is your ductile. Ductile means more expansion. Ductile means no chance of sudden failure. No chance of sudden failure. That is why they are saying that this value is 0.87 Fy by E plus 0.002. How this value is coming, I will say later, but not here because we're talking about the assumptions. Okay. Now we talk about the assumption number 3. What is your assumption number 3? Relation between compressive stress distribution in concrete and strain may be assumed to be rectangular, trapezoidal parabola. So either the stress strain curve should be parabola, trapezoidal, or rectangular. But in Indian context, we'll find from experiment that this is our curve. This value is your maximum value. So this portion is some straight line, but this portion is some parabolic. Okay, and that is value of FCK, and this is your strain, and that is your stress. Okay, and this value is your 0.002. This is the yielding. Yeah. And this full value is your 0.0035. So that means this is your what 0.0015. So this 0.0015 is your plastic strain, and this is your elastic strain. This is reversible. This is your non-reversible. You can say permanent. Permanent. Okay. I hope this understand. Okay. But this value we'll find in the lab. But in fact, we found not this value. We found less than this value. This value is known as your 0.67 FCK. 0.67 HCK. This is the value we found in this field. And in design, what value we assume? What value we assume? 0.67 HCK divided by gamma m. What is gamma m? What is your gamma m? Gamma m is your partial safety factor. What is partial safety factor? Now we take you. Now I will tell you the real scenario. What is the implication of? What is the implementation of FCK? FCK into 0.67 and FCK 0.67 by gamma m, and this gamma m value is 1.5. Okay. Suppose you are civil engineer. Not suppose you are civil engineer, that is why you watching this video. Your grade of concrete is M25. M25. Okay. In field, I assume that the 25 you are not getting, you are getting 66% of 25. That means 2/3 of 25. 2/3 of 25 means 2/3 of 25 means say 60. I assume that you are getting 60. But so I assume that I will design the whole structure in this value. That means 16 by 1.5. 16 by 1.5 is 16 into 10. Simple mathematics. 15, 2, 3. So this is approximately 5 point something, so approximately 10. I assume that I using this structure as a M25. I designed the structure is 10. So suppose your compression for M25 you need 50 bags cements. But I designed for 10 bags. So I am applying this 50 increasingly. It will occur or it will happen, say 70 bags. So for M25 you need 50 bags cement. As for design you need 70 bags. So these 20 bags, this is your safe zone, and this is your safety. This is your confidence. So that is all about this beautiful game-changing limit state method assumption. I hope that is very beautiful and you will understand. So next we talk about the number 4 assumption. What is number 4 assumption? We know that concrete is beautiful grade or concrete is considered for compression. Steel is for tension. Okay, but concrete has a minimum tensile force. Minimum. If you are good, there is some bad portion. If you are bad, you have some good portion, but we cannot ignore. So definitely, concrete has a minimum tensile force, that is 0.7 root FCK. I hope you understand. But we do not in future कभी भी will not consider the tensile force of concrete that is written in the D. The tensile strength of concrete is ignored. Okay. Number 5, partial safety factor of steel is 1.15. Now, many of you have some question. If you have no question, then some of you definitely asking you why gamma steel is 1.15 and gamma M concrete is your 1.5. Why? Why? Now here is the answer. That is the beautiful of the civil engineering. Everything has some reasons. इनका मजा नहीं आएगा भाई. चलो बात देखते हैं. Steel is homogeneous, whereas concrete is your heterogeneous. We assume that it is homogeneous, but it is heterogeneous. Why? Concrete is not a prime material. It is a material which consists of cement, water, sand, coarse aggregate, that is stone or aggregate. Quality control is very much very much controlled, whereas this is very low. Why? Concrete to making in anywhere, but still you should have the steel plant. You will not make steel in the your construction site. Okay. So these are the few reasons. That is why partial safety factor is 1.15. This is partial safety factor 1.1. Quality control is controlled. That is why we have more confidence in the steel, less confidence in the concrete. That is why partial safety factor of concrete is greater than steel. I hope you will understand and you have some clarity about why 1.15 and why 1.5. Okay. Last point. I will say this. This is the last point. The maximum strain in steel 0.002 plus Fy by 1.15 ES. How the values come? Okay, let's understand the stress strain curve. This is your stress. This is your strain. This is your elastic zone. And this is your plastic zone. Okay. Elastic zone, the value is 0.002. And this is your maximum strain. We have to calculate maximum strain. So we found this portion 0.002. What is this portion? What is the value? Strain. Simple. Strain means what? Stress per elasticity, because we know that stress proportional to strain, stress equal to E into epsilon. So epsilon equal to stress by elasticity. Okay. Whose strain? Steel strain. So this steel by ES. But in our design, sigma S should be maximum value divided by partial safety factor. That means gamma steel by 1.15. This is, we say, is y is by 1.15. So what happened? E is equal to Fy by 1.15 ES. And this Fy by 1.3 0.87 Fy. So E is equal to 0.87 Fy by ES. Okay. So what is total value? The total equal to 0.002 plus this. So we can say equal to 0.002 plus 0.87 Fy by ES. I hope you understand. So there are some value you can remember, you cannot be remembered. It's your choice. If Fy equal to either 250, 415, 500. Okay, Fy means yielding strength, design strength. Okay. So in this scenario, XU max by D, that is equal to 0.53D, 0.48D, 0.460. I tell you that never ever remember this value. When you start the RCC design, I will tell you how you find it. Okay. Just understand the assumptions. Okay. So in my next video, I start the limit state of collapse, that is compression. We talk about the flexor, then we talk about the compression. So in this video, basically I talk about the assumptions where I discuss the 5 to 6 value, 5 to 6 assumption with the proper explanation. Hope you understand. If there is any kind of doubt, definitely do in comment in comment section. And if you get some value from this video, then definitely spread this knowledge, because knowledge is one thing that can enrich you, save you from every place. So, wish you all the best. See you soon in next video.